Hey, it's Clay. Welcome to another video. This is going to be the next installment in my series talking about how guitar gear works. One of the questions that I often see on internet forums talking about effects pedals or amplifiers is how do you learn more about designing circuits and going beyond just kind of the paint by numbers, build it yourself type setups. And I think one of my answers to that question is to start learning about how the individual components in your circuits work. So we're going to talk about resistors as one of those very common building block components of any circuit in electronics. Some of this information will apply to electronics in general, but I'm coming at this more as a DIY guitar, pedal, amp related gear. I'm not an expert in electrical engineering, so I'm very happy to be corrected on anything I've got wrong here, but hopefully if you are interested in taking the next step in learning more about how guitar gear works, this will help with that. So let's talk about the basics in terms of electrical engineering on what a resistor does in a circuit. I like to think about it like the brakes on a car. You have current flowing through your circuit. You know, if you're making a guitar signal, that is an AC, an alternating current signal. And then you also have DC, which is usually in the form of your power supply. All of these signals are flowing through your circuit at various places. And resistors helps to regulate or to break the flow of those currents through your circuit. And how they do that is you have the signal that comes in, and then depending on the value of the resistor, they convert some of that energy into heat, and they dissipate that into the air around them. And really the other thing to keep in mind is that the flow of electricity in your circuit, it doesn't really like seeing resistance. So one of the things you need to remember is if a current flow is coming to a certain junction in a circuit and it sees a path where there is resistance and another path where there is not, it is going to favor the path of least resistance. And so that's why you want to think about it like a brake. The flow of current is going to be slowed by your resistor, and it doesn't really like that. But that is how it functions in an electrical engineering context. Next, let's talk about some of the basics. This is a picture of a resistor. You can see here it's got two leads on the outside and then this kind of cylindrical center. Sometimes you can see this one has some ridges, sometimes it's kind of a solid cylinder. And it also has these bands that you can see of different colors. You've got gold, orange, red. There are a bunch of different colors, which we'll get into here in a second. One thing to know about this, it is non-polarized, meaning that it doesn't really matter which end you put in which position in the circuit. You can put it forwards or backwards, it doesn't really matter. And then lastly, on the bottom right, that is the symbol for a resistor in a schematic. It's got this kind of wavy up and down line. And you can see that is the symbol that you should keep an eye out for if you're looking at a schematic for what a resistor is doing. So now let's talk about important specifications. We're going to go through them as an overview right now, and then we'll go into them individually here in a second. So first of all, obviously the value of the resistor. Now resistors are measured in ohms, and then it uses a metric scaling where you have ohms, 50 ohms. That's just kind of your baseline value. And then kilo ohms would be adding 1,000 to that. So if you have 1.5 K, that would be 1,500 ohms. And then you've got mega ohms. That adds 1,000,000. So 1.5 M would be 1.5 million ohms. And so that's a really nice thing to know about obviously the specification of the resistor is its value. That is one of the primary things you need to know. The value is often depicted on a color code on the edge of the resistor, and we saw that with that first picture, how we've got those colored bands, and we'll go into that more in here in a second. Next thing also to know is that resistors have a tolerance, and this is very much dependent on the era of the resistor or the type of resistor, the construction, which we'll get into here also. And tolerance refers to, so if it is stated as a 1.5 K resistor, the percentage tolerance will supposedly guarantee by the manufacturer how close to that value it is. So I've seen some resistors that have a low tolerance of like 20%, whereas other resistors have like a 1% or even a little smaller than that, a 0.1% tolerance. And so it just depends on how specific you're trying to get. And we'll talk a little more on that here in a minute. Different construction types certainly play a role. I would say there are baseline resistors that will cover maybe 90% of applications, but then typically as you get into higher wattage ratings or power ratings, then you want to consider using different construction types. So let's dive into those specs a little bit deeper. So let's talk about resistor value. How do you determine the value of a resistor? Just by looking at it. Well, for the most part, when you buy resistors, they will come in packaging that will state the value of the resistor. And you can kind of organize that in such a way that it is easy to access based on the packaging. However, that's not always available once the resistor is out of its packaging, or maybe it's in a circuit. That doesn't help you. So next, you can use a multimeter. Now with a multimeter, you need to have the resistor out of circuit, or at least one of the legs out of circuit. And then you can put the multimeter into a resistance mode and put your two leads on each end, and that will read the value of the resistor. In my opinion, this is an excellent way to determine the value of a resistor, because again, we talked about tolerances before. You know, if the tolerance of the stated value is high, it may not really be applicable for that circuit. Also, reading color codes, which is something that we'll get into here next, can be a little bit cumbersome, and so using the multimeter is the best way to guarantee that you know exactly what the value of the resistor is. It also takes out any user error. Sometimes reading color codes, you might make a mistake, or you'll kind of rush and you'll get it wrong, or even the way that things are packaged might be wrong. I've even had a very, very infrequently where a resistor, the bands are wrong. And but these kind of errors will happen, and the multimeter just guarantees that you have the correct value resistor before you put it into circuit. So it does take a little bit extra time. It can be a little bit of a hassle, but it is probably the best way to guarantee that you know the value of the resistor. Then we have color codes, and you can see I've got a graph or a kind of a chart over here on the right side, and you have these various different colors. And with most resistors, they are either 4-band or 5-band. And you can see on the top there's a 4-band code, and then on the bottom there's a 5-band code. They function very similarly. So with a 4-band code, the first band is a number, the second band will be a number, and then the third band, or I'm going to call it the second to last band, is your multiplier. So you take whatever your first two numbers are, multiply it by the multiplier. And then your last band gives you your tolerance rating. So just as an exercise, if we look at this resistor here with the 4-band code on the top right, we've got a green is the first. That signals 5. Blue is second. That signals 6. So we know the resistor is 56. Okay, so we know it's a 4-band, so we need to go to the multiplier next, which is yellow, which is times 10K. And then, so we had 5, 6 times 10, you add a 0, so you have 560K. And then the last band is brown, that's your tolerance of 5%. It looks a little bit goldish, actually. So this resistor here is a 560K resistor with a 5% tolerance. So let's exercise it again. If you go down to the bottom, the first band is red, so that signifies 2. Second band is orange, that signifies 3. Third, now this is a 5-band, so the third band is kind of just an additional number like the first two. And then you still have that same rule where the second to last is your multiplier and the last is your tolerance. So if our third is purple, that's 7, so we've got 2, 3, 7. Then this second to last is black, that's our multiplier, so it's just times 1 ohm. So you have 237 ohms with again a brown tolerance, which is 1%. So 237 ohms at 1%. Now, just to give you some opinion on reading color codes, I've been doing this for several years now, and I would say that I am mostly able to read the numbers and remember. I've kind of have just the repetition memorized. Red is 2, orange is 3, yellow is 4, etc. But I would not say that I am so experienced that I can just instantly read a code by scanning through it once. I usually get tripped up on the multiplier and oftentimes have to look it up. So, I would say that it is helpful to know the color codes, but it is maybe not 100% essential, just because, like I said, I do think verifying with the multimeter is a very good step, and it kind of alleviates some of the need to memorize this. But if you are going to deal with resistors a lot, I do think it is very, very helpful to have some familiarity with this. And when you're building a pedal or an amplifier, have this diagram printed off and with you, so you can kind of quickly double check on what those resistor values are. So then next we talked a little bit about tolerance, and tolerance is just something to be aware of. It really comes down to how close to the stated value it will be. So the last resistor we looked at, I think, was 560K. Now, if that's a 5% tolerance, that could swing it up and down by 5%. Now, in most guitar applications, this is not a problem, meaning guitar pedals and amps have a certain amount of forgiveness to them, where it's really not so terribly critical that you get to like a 0.1% tolerance. The circuit will still work fine. Now, there are certain values in your circuits, though, where that can be kind of critical. But I guess overall, it's just something to be aware of. And tolerances are really important to understand with pedals in general. A lot of the times people might do a shootout between two pedals of the same type. Like, let's say we've got tube screamers from two different companies. Well, the truth of the matter is that depending on how the tolerances of all the components in that circuit swing, you might have 100 components. Maybe that's a little much. Maybe you have 50 components, and maybe they all have a 5% tolerance. That could mean that one pedal will have a very different sound than another just based on tolerances alone, where you're adding up the difference between all of those little component differences. So just something to keep in mind as you're building your circuits. So next, let's come to resistor types. Now, I'm going to be stating some facts and also providing some personal opinions, so take that with a grain of salt for what it's worth. First, we've got carbon comp resistors. They are the dark brown ones with the solid cylinder you see at the top of the images there. Carbon comp resistors are the oldest type of resistors that were used for many years, up until about the 1970s. So a lot of the vintage style circuits for amps and pedals used carbon comp resistors. However, they are not, I guess per their specifications, they're really not the best resistors. And by that I mean their tolerances are usually somewhat high. They also have fairly high noise compared to other more modern resistors. And also they are just prone to dying over time. For the vintage resistors can sometimes be in spec, but they certainly can stray. And they're just not necessarily the most robust compared to maybe some other types. The other thing I will say is there tends to be a little bit of a mystique around carbon comp resistors because they were used in those old vintage style circuits. And sometimes I think that can be a little bit of snake oil marketing. Whereas if you have an advertisement for a high-end amplifier and it's saying we use vintage correct carbon comp resistors, and they're kind of touting that as this good thing, I guess in my opinion, I think that really carbon comp resistors bring as many negatives with them as they would positives. And ultimately, some people have had the opinion that there are differences in tone or feel. I personally have never found that to be at a level where it is even something that you can really know or feel. Also, it's very difficult to truly A/B and compare in a fair manner because of the tolerance issue and just because it's really difficult to replace all the resistors quickly so that you can get A/B sound clips. And maybe that'd be a good video someday, is to just test different resistors in a very simple circuit. But I guess I'm just going to provide the personal opinion that carbon comp resistors on their specifications have the most negatives and drawbacks. And so I don't think that it is a positive that they would be used in a circuit, and I would prefer more modern resistors. Next, we have carbon film. This is a little bit of a step up from carbon comp. They are usually inexpensive. They have a little bit more improvement, but maybe not quite as good as some of the newer resistors, which gets me to metal film. Those are, I think, the most common modern resistor type that's used. You can see the third one down with the blue casing. That's a metal film resistor. They typically have low noise, about 1 or 2% tolerance specification. They last a long time, they're widely available, and they're very inexpensive. In my personal opinion, you should almost always be using metal film resistors in your circuits. And really the only other way that I would use carbon comp is if you're repairing a vintage amp and you want to maintain the vintage look of the circuit. Putting all those carbon comp resistors in vintage amps does have a certain look and aesthetic to it. And so if you're trying to maintain that vintage look, stay with that. Then on the bottom we've got wire wound. Now it's a little deceiving because wire wound resistors are typically quite large. It's kind of that white brick looking thing. Wire wound resistors are usually used for higher power ratings. And so if you're using like a 5 watt or a 10 watt resistor, like in a power supply of a tube amp, that's where you would typically see them being used. Metal film resistors have some limitations when it comes to wattage rating. You typically see them 1/8, 1/4, 1/2 watt. If you start getting to 1 watt, 2 watt, 3 watt, 5 watt, 10 watt, then you need to jump up to some other types of resistors. And then there is another type that they're blue. They look like metal film, but they have a little bit of higher power rating. I apologize, I'm slipping to recall them at this moment. But typically, like I said, it's more about power rating. That's why you would need to use something other than metal film. And then lastly, SMD. This is surface mount, and these are little tiny itty bitty things. I don't have a lot of experience with them personally because I mostly do through-hole components, but just want to make you aware that surface mount really are commonly used. If you have a pedal that is a very, very micro enclosure, chances are it's using a surface mount resistor, and they are proven to have high performance. So next, let's talk about wattage. Now this is the power handling of a resistor. You can see on the right I've got this chart where typically the wattage rating of a resistor is important to know because it will first of all determine the physical size of the resistor, right? A 5 watt resistor is going to be quite a bit larger than a 1/8 or 1/4 watt. And most PCBs are designed with a certain size of resistor in mind. And the main idea here is you just want to make sure you've got enough headroom, that the signal passing through your resistor has enough headroom to pass through. So you could use 1/2 watt or 1 watt resistors all throughout your circuit, but with typical guitar signals, we're talking about something on that's maybe a couple hundred millivolts, and so the voltage is just so low that I think I did a calculation once for the wattage requirement. It was like 0.016 of a watt, which is even an 1/8 watt resistor would be very magnitudes of sufficient compared to what was required at that stage in the circuit. And really with wattage, I think you should just be thinking about it. If you've got like a tube amp, that's where you're going to need to start thinking about higher wattages. And if you do want to calculate it, I did provide this graph here. You've got your power rating on the top left. In the middle one where it says I times V, that's current times voltage drop. That's really what I think you want to know. And now a lot of the times though, you might need to do some conversions because you maybe don't know those values. So specifically on the bottom right where it says R ohms in the orange, if you know the resistance of the resistance that you would know of your resistor, you can use some of those formulas to figure out some of those other things. So for example, if you have, if you know the amount of current that your tubes are going to be taking, you could, and you know the resistor, then maybe you could go up to your voltage on the top right in the pink, P divided by R. That would, you take your, I times R. And that would help, so that would be your current times your resistor rating. That would give you your voltage. And you could plug that into the top left where it's I times V. And then you take your current times your voltage, which you just figured out. And that will give you your power rating. So just want to make you aware of how to calculate that. But for the most part, if you're using 1/4 watt resistors in a pedal or an amp for the audio signal, that's going to be perfectly fine. And then if you're dealing with a power supply, that's where you need to start thinking about 1 watt, 2 watt, 5 watt, 10 watt power ratings. Now, I just want to comment lastly on buying resistors from a practical level because for a long time I bought resistors on an individual level and maybe wasn't always so efficient about it. So if you go to a place like Tata Electronics, you can buy little quarter-watt resistors, and they're like cents, like 2 or 4 cents per resistor. And so really, if you're paying like a couple dollars for a couple resistors, you're getting ripped off, because resistors are pretty inexpensive, and these metal film 1% resistors really do not cost much. Small Bear is another place where I bought components before. Mauser is also a place where I bought components before. Mauser usually has really low prices on certain things, but it is a little bit more complex to figure your way through their site and find exactly what you're looking for, because they provide a lot of different types of things for people. And then lastly, I want to comment on the Amazon multi-packs. I have purchased 2 Amazon multi-packs. So basically you pay about 15 or 20 bucks and you get a pack of resistors. It'll be like 1,000 of them. And it'll have values all the way from 1 ohm to 10 meg with all the intervals in between you could want. And you'll have maybe 10 or 25 individual resistors of all those values. Now, I am a fan of doing that because it really lets me, I never have to think about buying resistors if I'm going to start building a new pedal or I'm working on a new project, because I just pull from my multi-packs. And it also lets me experiment. So if I want to get into breadboarding or if I want to make some modifications, I have all the values of resistors that I could want. The other approach is you could choose to build up your stock by, let's say you pick a circuit that you want to build and you choose to build, let's say it calls for 3 10K resistors. Well, maybe instead of 3, you buy 5 or 10. So you just take whatever values you are buying for your project and you just multiply it up. And again, with Tata, if they're 2 cents per, it really isn't going to make a big impact on your price. But then you are buying all these extras of common values that are being used in circuits that you're actually building. And the nice thing there is, if you buy a multi-pack, you're going to have hundreds of resistors that you'll never use. I mean, there's so many. I mean, I've got like 20, 6.8 ohm resistors, and I don't think I will ever use a 6.8 ohm resistor. But I've got like 20 of them, and so there's a little bit of waste there. So this is maybe a more efficient way to build up your stock, so you can be kind of flexible, but you also aren't buying a bunch of stuff that you would never use. So that ends my presentation on resistors. I hope you guys enjoyed this. If you have questions, please leave them down below. I'll be happy to answer. Or if you have corrections or updates to things that I've made that might be wrong, I'm happy to learn more. Please leave that down below as well. So thanks for checking it out, guys. Hope you stop by again soon. Thanks. Bye.